you have seen earlier, both Joshua and also Jiahong's point of view are different. This is because they are both moving at straight lines. This is what we call the rectilinear motion, but in translation motion, because the escalators are moving them in different directions. Therefore, relative motion can be seen between both of them at different perspectives. Therefore, Group 6 will be conducting an experiment related to relative motion between two particles, which we have set as particle A and particle B, both moving down two different inclinations of 15 degrees and also 30 degrees. However, the distance traveled was set at 70 centimeters for both. So the time taken for each particle to travel that 70 centimeters were denoted and further calculations were done.
So basically this will be the experiment we'll be doing of relative motion. One ball being at point A and one ball being at point B, one being at a higher inclination than the other, where A is at 30 degrees and B is at 15 degrees of inclination. So both of the balls will be released at the same time, and the time recorded for it to reach to the end will be used for further calculation in a later stage. So this is the free body diagram of motion particle A, where it's at being at a higher inclination plane, where the ball is resolved into two x and y axes. This is the free body diagram of motion of particle B, which is at the smaller angle of inclination of plane, and the ball is resolved to x and y axis. So this will be the kinematics equation that we'll be using for this experiment, where v equals to the displacement over time and acceleration a equals v over t, which is velocity over time. So the velocity will be subbed with the displacement over time, and the final equation that we get from acceleration is displacement over time squared. This is the relative motion equation we'll be using for this experiment, where point A is a high inclination of 30 degrees and point B is a lower inclination of 15 degrees, where point B is going at a certain velocity, observing point A at different velocity. Hence, velocity of A in respect to B is formed equals to velocity A minus velocity of B, and velocity A and velocity B is resolved to the I and j component as shown below here. This is the relative motion equation of acceleration of point A in respect to point B, where acceleration A and acceleration B is resolved to the I and j component.
As you can see here, the velocity of A with respect to B is as shown here, and after obtaining the overall velocity of A with respect to B, we can derive it in the I component and j component as shown with Vx and Vy. However, these magnitudes are still in their components, which needs to be further derived so that the overall magnitude of velocity A with respect to B can be obtained, which is done by using the Pythagorean method as shown here, and the angle can also be obtained by using the inverse tangent of fraction velocity in y component over the velocity of x component. So this is how we obtain the values. Since the equation for velocity is the displacement over time taken, so the distance traveled, which is 0.7 meters or 70 centimeters in our case, is divided by the time taken to travel that distance, and being multiplied by cosine of 30 degrees for the I component, and also multiplied by sine 30 degrees for the j component. However, the negative values or the negative signs must be used because we have taken our experiment where the x component is positive in the right direction, and for the y component it's positive in the upwards direction. The same can be seen for velocity of b, but then by using the angle of inclination 15 degrees for both cases. With the general formula obtained, now we can obtain the velocity of A and velocity of B in vector forms, which are as shown here. With the time taken for A to travel 0.7 meters, which is 0.55 seconds, and for time taken for particle B to travel 0.7 meters is denoted as 0.79 seconds. So these values will be obtained, and now by using the relative motion equation of velocity of A with respect to B, we can obtain this full vector form. And now, after the magnitudes of I component and j components are obtained, we can use the Pythagorean method to obtain the overall magnitude of velocity A in terms of B, which is 2 meters per second. And for the angle, we can denote it as the y component over the x component and inverse tangent of this fraction value. So we can obtain 11.7 degrees.
The same can be said for the acceleration at point A and acceleration at point B. However, the value inside here will be different since acceleration is displacement over time squared. Here, after subbing in the TA and TB, we can get the values. After subbing in TA and TB, we can get the acceleration A in the vector form and acceleration B in the vector form. Then using the relative acceleration equation, we can get the overall value such as this. The value for magnitude of acceleration AB can be obtained using the Pythagoras theorem, and here we get 3.21 meter per second. And for the angle, it is the arctangent of y over x, and the value is 16.05 degree. So for our final results, assuming that upwards and right are the positive direction, we can get that the velocity of A respect to B is 2 meters per second and the angle of 11.8 under the x-axis.
Hence, for the acceleration of A respect to B, we can calculate as 3.21 meter per second square, and it goes downward at an angle of 16.1 degrees. And this is the result.